Okay, thank you everybody. We'll get started now. So welcome to our digital thread, the third in our series of digital thread presentations presented by PDSVISION. Our agenda will be introduction to PDSVISION and myself, and then moving into our topic overview, what is digital thread? And in this series, we'll be focusing on as related to prototyping. So my name's John Hughes. I'm a technical specialist with PDSVISION, formerly Boundary Systems. I'll be 3 years soon. My background is 25 plus years as product design utilizing the PTC family of products, and 20 plus years mostly in the plastics industry and application and design and development, utilizing injection molding, design for injection molding, and simulation to validate and optimize design and recommendations. We are PDSVISION, formerly Boundary Systems, a technology leader and first PTC global reseller and preferred services provider, a software solutions developer for design and manufacturing. Some of our capabilities include consulting, implementation services, professional training, cloud, help desk. Some historical background: Boundary Systems founded in 2006, PDSVISION founded in 2008. 2009, Boundary Systems becomes a preferred Windchill partner with PTC and expands its global operations into South Africa in 2014. In 2018, we are acquired by the PDSVISION group, and further expansion and acquisitions in 2020 of NET in Germany. And in 2022, we officially changed our name from Boundary Systems to PDSVISION. So, as well as being a proud strategic partner with PTC, we also have partnerships with other engineering software and software development companies, such as Moldex 3D, which is utilized for injection molding design, simulation, optimization, and validation, as well as Tacton, Xformation, eTroj, Sigmaxim, ZWCAD, Keyshot, which was highlighted in our Series 1 digital thread presentation, ITI, and Cimerix. So some focus areas throughout the whole life cycle, from product design, conceptual to end of life, will include CAD, CAM, simulation, data management, IoT, and product life cycle management, and all these intersecting and merging throughout the whole entire process. So the digital thread concept essentially promotes the transmission of the correct information to the correct people or place at the correct time. So with that said, in Series 1, we were introduced the concept development from our industrial design department. And Series 2 was engineering design, where we reviewed the concept designs. Various engineering changes were made. Change notice and tasks were assigned for the next stage in this process. So here in Series 3, we'll be looking at tasks assigned from the change notice, focusing on prototyping. So everything we're working on is within Creo and in Windchill. So we go into our Creo, we can look at our Windchill folder. So this is the project. We can go here and review the tasks that were assigned from the previous. So we have 2 tasks assigned. One is optimize seat assembly, and for prototyping and create drawings. Here we can expand that to see the objects affected. Now I've already gone through the process of creating a workspace and checking the files out so I could continue with my work. Here we can access and open up the assembly so that we can proceed with working on our first task, which is optimizing the seat assembly for prototyping. So we're turning off some geometry, and this way we can see the parts that we have to work on for our task in the graphics window and or open them through the model tree. So we open up this seat assembly. We'll take a look at it. We notice that there is some mounting geometry for the bracket to the seat is missing. So this would be one of the tasks that we would work on. So we will go through and open up the seat, and we can create mounting geometry necessary for the bracket. So we'll open up the seat, and to save time, I've already gone through the process. We've created some geometry. I'm just going to resume it here. Create geometry for mounting on the one side as well as the other side, and then we can go back into our assembly and validate it in the assembly. So great, we've made some changes. This will be documented. Now going back into the seat, because we have to focus on this for prototyping. There's some options we could do. This could be 3D printed, vacuum formed, vacuum molded, or injection molded. We're going to focus on injection molding for this seat. So I've gone through and added some features that are needed to properly evaluate this in molding position. And so from here, what we can do is utilize the functionality within Creo for injection molding, and we're going to run a draft check analysis on the seat. Our direction is representing our parting line for our mold. So we run this, and we can see that there are some draft issues in the armrest area that would make this difficult or impossible to injection mold. So here we would have to go in and make some changes to the seat, to the freestyle. So we can go in here and we can update that. Once we've made some changes and we've saved that, we go back in and we do another analysis of the draft check to make sure that those issues have been addressed or resolved. So we see here, yes, our modifications have resolved the draft issue. So we can proceed to the next step. And this may include, again, for injection molding, some melt delivery system considerations. I mean, this is a rather large part. So we can start laying out some a runner system. And here again, I've taken the liberty, I've already done this, and I'm just showing it for expediency. And from here then, once we have some approximate dimensions and positioning, we can also then utilize additional functionality within Creo to analyze this in a mold analysis extension. So here we can assign materials, specify gate locations, processing parameters, and then we can go through and process the analysis. So we've worked on the seat for prototyping. Again, some options: 3D print, injection molding, vacuum molding is other. We've gone through and added mounting geometry for the bracket. We've reviewed for injection molding, processed draft check, made changes to the seat to address those, and then we've done some preliminary melt delivery option layouts. And we've gone through, and now that we've completed the molding analysis, we can review the results. So here we can do some selections here. Moldability, this is a great indication. It would tell us if there were some potential problems. But what we primarily want to focus on is the balance of filling, and if we need to tweak locations in that. So here we can go through our animation controls, and we can run the animation. Shows the material flowing through each gates and filling the part. We can simply stop this if we want and go to the end, and then we can backstep and we can see the end of fill, which is very critical to make sure that we've got an optimal gating scenario And here we see that we've got end of fill in the arms, the headrest, and the shoulder. So this is a very well balanced part. Again, if needed, we could have made additional changes and run additional simulation, all within Creo. So now that we've evaluated the seat, we need to focus on the next half of our first task, which is the bracket. So the bracket prototyping can be 3D printed, milled, or cast. It's currently designed as a sheet metal, but we can open this up and use further functionality in Creo under Applications, Generative Design to explore various manufacturing options. So, utilizing generative design extension for the bracket to create and evaluate various options for manufacturing, such as milling, cast, and additive manufacturing. This can be processed on a local machine or cloud-based. And we simply select design spaces, we add loads and constraints, define objectives, specify the material, and choose or select manufacturing processes for the scenario to evaluate. Creo will calculate the optimal design to meet those requirements. We have a milled part, a cast part in the middle, and on the left, a 3D part for 3D printing, which is the direction we will go. So once we've determined the manufacturing type, and we're going with a 3D printed part, we can utilize additive manufacturing to design, optimize, validate, run a print check, and determine the optimal build direction based on our specifications. This reduces processing time and can prevent mistakes. And then we can simply send it straight to the 3D printer. So the 3D printing formats within Creo allows design applications for full fidelity 3D models to a mix of applications, platforms, services, and printers, all from within Creo. So a model has been created through the generative design, and from there we've created a Creo part file for 3D metal printing. And we can use this model then within our application to update the chair and bracket, seat and bracket assembly. Now, change task 1 has been completed. The seat assembly has been optimized for prototyping. We can review the next task, which is creating assembly drawings. Now, we can either create a 2D drawing or using model-based definition, we can utilize 3D annotations to provide and reflect important and relevant information. These can be shown annotations from existing geometry, whether features, or it can be added dimensions by adding them and creating them on the fly. And once this is done, we just show the annotations, and then we can share this at the next stage. So again, we can either create a 2D drawing or utilize 3D annotations. In this case, we are providing 3D annotations to provide important and relevant information. For the seat here, we have some dimensions for basically the overall size that will be important for calculating the mold base. We have some dimensions to lay out the melt delivery system and critical information here like slide action on both sides, as well as some dimensions that are critical for this for mounting the brackets. And likewise, when we do the 3D printing of the bracket, the important and critical information on here is the dimensions for the geometry to mount the bracket to the seat, as well as then to the automobile. So now we've completed all of the change tasks. And at this point, once we're finalized with our work, files can be checked back into Windchill for the next stage, which would be process planning. So that completes our overview of this portion of our digital thread presentation. If you have any questions, we can take time to answer these here and or to follow up through an email or potentially scheduling additional Teams or screen sharing meetings. So we'll wait for a few minutes and see if there are any questions. And while we are waiting on questions, our training capabilities here, if you want to learn more, our webinar topic presenters are all certified trainers, and we can dive deep into each topic, and we are open for new topics, suggestions for new topics. Training is available virtually, in center, or on site. Please check our website for the full schedule of training classes, webinars, and hands-on workshops. Thank you for your time. And if further information is required, my contact information is here, jhughes@pdsvision.us, as well as sales@pdsvision.us. Again, please check out our website and our YouTube station. So again, thank you for your time. With that said, we will stop the broadcast or stop the presentation and can address any questions offline. Please also stay tuned for our next installment, Series 4, in our digital thread presentation. Again, thank you for your time and have a good day.